Okay, absolute value of a function. So we've got the table of values for y equals 2x minus 6, which we know some stuff about, right? It's a line, it's a linear equation. It has a slope of 2. It has a y-intercept of negative 6. We honestly don't even need the table of values to graph it, but we have a table of values. But what we really want to do is be looking at, okay, compared to y equals 2x minus 6, what's the absolute value of 2x minus 6? So what goes in here? 6. Okay, so we know the absolute value says take whatever value, right? Evaluate the expression and then make it positive. So the expression's already evaluated, and then we're going to graph these two, right? Use table values to sketch. So I'm going to do 2x minus 6 in red. Okay, so what have we got? 0, negative 6, 1, negative 4, 2, negative 2, 3, 0, 4, 2, 5, 4, 6, 6. All right, and then we can draw a line. Draw it down. All right, so there's that graph. And in green, I'm going to do the absolute value. So at negative, when x is 0, we have positive 6. When x is 1, instead of negative 4, we have positive 4. At 2, it's 2, 0, and then these guys are actually the same points, right? So if I sketch that graph, and I suppose we should label these, right? So let's label this. This is y is equal to 2x minus 6, the red graph, and the green graph. This is y is equal to the absolute value of 2x minus 6. Let's do the red in red. Okay, so we observe. How do the graphs compare?
It's a straight line problem.
That is not a parabola. It's a V. Yeah, parabolas are rounded at the bottom, right?
One's only positive.
One's only positive, right? Yeah. So we take the negative red. So what have we done with the red line that's below? Yeah, we reflected it in the x-axis. What do we do when we reflect stuff in the x-axis? What's the transformation?
Isn't it just the A value?
Yeah, the A value becomes what? Negative, yeah. So making the A value negative. All right, so just keep that in mind, right? So all we're doing now is just some observations. Okay, well, we took the branch that was below the y-axis and we reflected it in the y-axis, right? So this point was 2 units below, this point's 2 above. This point was 4 units below, 6 units below becomes 6 above. Okay, interesting, right? Oh, I guess we could write that out, right? How do the graphs compare? The graph of the absolute value, I'll say y equals, is the same as when y equals 2x minus 6 is 0 or is greater than or equal to 0. So in other words, when 2x minus 6 is positive, we just got the same graph, right? The green line is on top of the red line, right? So if you're graphing this on your graphing calculator, and you had the color one, right? So there's ways of remember the ways of checking with your graphing calculator. So like yesterday, you could have graphed the one equation and then graphed your vertex form or whatever to say, okay, are they the same? If you have a color calculator, you're just looking for one color line to overwrite the other. And if you have a black and white calculator, then you can set it to a thicker line, right? And you can see, oh, it drew a line, and it's drawing the line right over top of it. So I know those are the same graph, right? Or, wait a second, it's not drawing it over top, so something's different, right? So I've made a mistake, I'm gonna have to look at that. So in this case, this branch would just go over this, and this branch is reflection. So for negative values, the negative values of y equals 2x minus 6 are reflected in the x-axis. Okay. Complete table of values shown for the functions y equals x squared minus 6x plus 5 and y equals the absolute value of x squared minus 6x plus 5. Use the table of values to sketch the two graphs. On the grid shown, how do the graphs compare? Okay, so let's scooch this down a smidge. 150 do it? Well, that looks like about 150. 125. That's better. Okay, so I'm going to pause this, right? Okay, so there's the first graph, which is just the table of values. We didn't do any calculations. We didn't do anything to it. We just graphed the points. Not all that well, because my line should be going through 5, 0, but it doesn't. But, yeah. So that's the red graph, is the original graph, x squared minus 6x plus 5, and now we're going to graph the absolute value graph, and I have the points already written down. Okay, so I plotted the points, and we could see that point the same, that point the same, that point the same, this point same, this point same, this point same. These guys are different, okay, because we're doing the absolute value, so a value that is negative becomes positive. Okay, now we know that what we're doing then is reflecting in the x-axis. So what's different here is this section here, which is a reflection of this section here. So it's, you know, this is not a straight line to here. This is a reflection of this branch of the parabola. Okay, and then I need the rest of it, which will be the same. I'm going to kind of sketch in the vicinity. And this one I'll try and actually get where it's supposed to be. Bless you. Okay, so here, these are the same. And these are the same. And in the middle, they're different. Okay, in this area, because those points which were negative in the original function become positive when we take the absolute value, right? So absolute value function says evaluate, right? Treat it as a set of brackets. Whatever is between the absolute value bars, you're going to evaluate, get the number, and then you're going to look at it and say, if it's positive, I'm going to leave it. If it's negative, I'm going to make it positive. And the way we do that is to take the negative of it, right? Remember when we defined the absolute value function, we said it's x if x is greater than or equal to 0, but it's negative x if x is less than 0, right? That's how we make a negative into a positive. When you graph, what's that mean? Well, you make this negative 4 into a positive 4. You're basically reflecting in the x-axis, right? So any points which are below are reflected and come up above. Okay, so how do the graphs compare? Yeah, we'll leave that, right? Just the same as the last set, right? So they're the same if these values are positive. Then I've got the same graph. If the original function's values are negative, then the absolute value function is, in effect, graphically, a reflection in the x-axis, right? Which, you know, so to draw it is really just saying, okay, this branch here just goes and reflects up to here, right? And I can just take these values, even without the table of values, right? That's at negative 4, okay, reflection's at positive 4. That's at negative 3, these guys are at positive 3. That's at 0, it's going to stay there. These guys are positive, just leave them. Okay, question? So the graph of y equals the absolute value of f of x is the same as the graph of y equals f of x, except the portions of the graph of y equals f of x that are below the x-axis are reflected in the x-axis. The points on or above the x-axis are said to be invariant points. Invariant meaning don't vary, right? They don't change because they remain unchanged after a transformation, right? So they are invariant, they do not vary. The graph of y equals f of x is shown. On the same grid, sketch the graph of y equals the absolute value of f of x. Okay, so what do we do for this part here?
It's the same.
Leave it the same. Okay, so let's say we're going to sketch this one in red. So this stays the same. What do I do for this, these guys? So let's just identify a point, right? So where does this point go? It's at -2?
2.
So it goes to +2, right? And then again, let's just take points we can find. This one's at -4. So it's going to go, right? There's no, oh, the scale's over here. So it's at -4, 1, 2, 3, 4. Which means we probably have a point at -6, 1, 2. That, all I can do, I don't even need to. I can just start here and just go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So you can look at the actual value and say, hey, that's the point, 18, -6. If I'm going to do a reflection in the x-axis, it will become the point 18, +6. Okay? And then I can find that point and graph it, or I can just start at that point and say 6 units to get up to 0, so it was 6 below. I'm just going to count 6 units up. And then graph this, straight line, arrows, right? Something that could possibly pass for a straight line. I can't draw a straight line. And arrows, and there we go, right? So the red graph, right? And remember, this is part of the red graph, right? The red graph is the graph of the absolute value. On the same grid, sketch the... Okay, so we could label this y is equal to the absolute value of f of x. You can't do it. F of x, right? Absolute value. Just make sure your bars are big enough so that if you're doing the absolute value of 2, it's not like, is that 121? Of course. Okay, what do we do from here to here? They're the same, right? So we're just going to sketch over it. So if you have a highlighter and you want to show your graph, you can just sort of highlight that, right? So on a test, just kind of sketch over this, make it darker, right? Or use a different color. I would advise not a highlighter at that point, but using a pen or something, right? Say, okay, I'm gonna risk it and try graphing this in pen. And then what do I do for these guys? So all I can do is find a point, right? And the only point I can see here is I've got the point 2, -6. So where am I going to move it to?
2, 6.
2, 6. Okay, so that point is there. And by symmetry, right, I mean, wow, it's not even, where else do I, at 5, sorry, -5, -6, so that'll be -5, 6. Okay, so then these 2 points by symmetry, if it's at -5 and 2, they're 7 units apart. So the axis of symmetry is 3.5 units from either end, right? So 3.5 units from 2 is -1.5, and 3.5 units from -5 is -1.5, right? That's where my vertex then would be at -1.5 or -3.5. Okay, to graph this, just remember, I'm graphing a parabola. I do not want to draw a straight line, right? It needs to have a little bit of a curve to it.
Which way does it
In.
Okay, so it's a reflection, it's going to curve in towards the...
I know. Looks like it's a gag wave.
Okay, so it's not a W. Because it doesn't have a point in the middle, right? It's got a vertex in the middle. It's a parabola. It needs to be curved. So, I'm not going to go all, but if you draw straight lines when they shouldn't be straight, especially if you basically, if you make the middle portion of something, which is a parabola, if you make that into a V, I'm going to ding it, right? I mean, you got to say, if it's an absolute value, absolutely, it's going to be a V, right? Like, it is just straight lines. If it's a parabola, try and indicate, yeah, there's a bit of a curve here, right? Like, The lines are never, there's never a straight line, right? Nowhere in here is the line actually straight. It's always going on a curve.
Why is curling gonna work?
Well, just take a point here, right? So this should be, so -4, so I need this to be up here for +4. Right? So this is here at -2, I need this to be here. So that's why it's, okay. So it's reflection. Right? I mean, I may have curved it a little more than I should have. I'll admit to that. Okay, you do these.
Oh my god.
Oh my God, not hard. All right, so, I mean, if we're going to graph these, you can just start by saying, hey, if it's positive, it stays positive. I'm just going to graph over top. But if it's negative, then, all right, I can see a point there, right? That's over here. And then these guys kind of curve out like that. Well, this point here is like -7, so let's go up here and hit it at +7. So I'm just going to kind of graph up like that. And then this point here, you know, again, you're just sort of, okay, it's about here. So this point is going to graph up like that. And then the same deal here, right? Now we're just eyeballing. We're sketching the graph, right? Okay. Especially for that, because there's no easily identifiable points. If it's a straight line or it's a parabola, it's a lot easier to identify. Okay, and then in this guy, okay, points that are the same, we'll do in red. Okay, this little loop here.
What is that?
Text sound. Star Trek, man. It's the view screen sound from the original series. Just a heads up, your e-bill is ready. It's like, I have automatic payment. I don't need a heads up. Right? Pay your bill by. It already gets paid. Okay, and what do we do with this loop here, right? Well, so we say, okay, it's about, yeah, what, -5 3/4, kind of, let's go up to here, right? And I'm just going to curve this line, right? And then same deal, it's just shy of 4, but it's at negative, it's about there, and I'm going to do that. So the red line is the absolute value graph, right? And over here, the purple line is the absolute value. So should probably be writing down this is y equals f of x, and this is y equals the absolute value of f of x, and this is y equals the absolute value. Okay, so for sure we're going to ask you that, right? Maybe give you a table of values. Say, what's the absolute values? Or give you table of values that aren't filled in. Give you a formula. You got to fill these values in, then we want the absolute value. For sure, you're going to need a graph, and it's going to say sketch the graph of the absolute value. That's seriously pretty easy, right? Okay.
So,
Yeah. They look a little weird, but the graph of now the graph of the absolute value is shown. What are possible graphs of the original function? And then determine possible equations. So yours being shown the absolute value. So in A, what does that mean? Could go either way, right? So we could say, okay, this was down here, right? Okay, so let's do that. We'll do that in red. So we're going to say this branch here, which is positive, well, maybe it was negative. So, you know, and it's a straight line, I can get a couple of points. This is like up 2, this is up 1, so that should be there. And this is, you know, 1, 2 that way, so I go 1, 2 this way. So there's the red line. So possibly that's what we started with, the red line, right? What's the equation of this red line? Y is equal to? What's the slope?
oh, it is on.
What's the slope of the red? Okay, wait. Now, so if I'm doing the red line, then this is also the red line, right? Okay, sorry. We didn't recognize that. What's the slope of that line? A half. What's the y-intercept of that line?
2.
2. So the red line is y equals 1/2 x plus 2.
Isn't it supposed to be negative?
There. It wasn't a negative, it was supposed to be like a dash. But yeah, then it looks like negative. Okay, so let's change that to an arrow. So the red line is y equals 1/2 x plus 2. Now, what's the second possibility? This was reflected up. So we're going to take it down, right? So this is 1 down, this is down 2, or sorry, 2 to get to here and then 2. Okay, and then this branch here. Okay, so what's the equation of the green line? So negative 1/2, right? So if we're looking at slopes like down 1, right 2, so it'll be negative 1/2, and then it goes through negative 2. So negative 1/2 x minus 2, right? No fancy stuff required, right? Fancy stuff's gonna be required here. Yeah, it's just a parabola. So what? 2 possibilities, right? So what's kind of the obvious one? What are we going to do? We're going to take the little hump in the middle and draw it down, right? So we're going to say, all right, probably, maybe what happened. So can we find a point? Yeah, at 2, it's 2. So at 2, I got to come down 2. Wait, let's do that in red. So that point's there, and then it's just a parabola, right? Okay, what's the equation of this parabola? You may give it in vertex form, because any other form would just be way too much work. You don't need to do it algebraically, you can just count, right, from the vertex. It's 2's everywhere.
2.
So y equals 2, bracket, okay, so the vertex is at 2, negative 2, right? Vertex form is y equals a x minus p squared plus q, so p is 2, so it's x minus 2, which also says what? It moved right 2, good, yeah, because it is, right 2, and down 2. And then the stretch factor, if I go over 1, I should be up 1, but I'm up 2. If I go over 2, that should be 4, and it's 8. So we have a stretch factor, positive 2. Opens up, positive 2, shifted right 2, shifted down 2.
Yeah.
What's the other possibility? That it opens down,
Okay.
right? That this was always here, and that these were reflected. I'm just going to do a lousy sketch because there's not much room down there, right? But it's just that, yeah, it's a parabola that opens down. Now, its vertex is in a different place too. Where is it? 2, 2. So it'll be negative 2, right? It still has the same shape, right? Shape is the same. What determines the shape? The value of A. Gives you 2 things, the shape and the direction, right? Positive opens up, negative opens down. So it's negative 2x minus 2 squared plus 2, right? Because we're not sure, when we move left or right, that's an x value, right? And when we reflect, that's a y value, right? The x value stays in the same place, right? What's happened here is this point is reflected down, so the y value changes. This value, well, from the original parabola that we found, this goes up here, right? Still, move 1 from the vertex, we're going 2 units, right? But down, so negative 2. Vertex is at 2, 2x minus 2 squared plus 2. Okay, questions? Right. So really that's like a state, right? Draw this and state the equation, because there's not a lot of work involved in getting that equation. 5. For y equals the absolute value of negative 3 halves x minus 3. Sketch the graph of y equals negative 3 halves x minus 3 by first sketching the graph of y equals negative 3 halves minus 3. A lot of that, right? I should have been saying, for y equals the absolute value of that, start off by sketching the graph of the absolute value. Nuh-uh, not first. Sketch the graph of negative 3 halves x minus 3. Okay? How do we do that?
By drawing.
You draw it. Okay, where am I going to start?
Graphing calculator.
No.
Oh, dang it.
Where are you going to start? You're graphing this. What is it? Is it a parabola?
It's a line.
It's a line. What do we know about this line?
It's a slope.
Has a y-intercept of negative 3. Okay, so here. And it has a slope of negative 3 over 2, which says from here I would go which way? Down 3, right 2, right? Negative 3 over 2. If you think of a slope, right, you can think of negative 3 over 2, which is down 3, right 2. And I'm just going to keep doing that. Down 3, right 2. Okay, I can't keep doing that. So I can also think of it as 3 over negative 2, which says go where? Up 3, left 2.
Hurrah.
Okay, so from here I go 1, 2, 3, 1, 2. 3, 2, 3, 2, 3, 2. You know me, I like to fill the grid, right? Because then what happens? Well, then I take my straight edge and I lay it down on the points and it lines up with all of them, and then I know I've got a good graph, and then you also know that I can't draw a straight line on this thing. And I should be using the technology to do it because it does have a line tool, but I can't, it would be black. And then I have to change the color and put arrows. No.
Can you make one?
I could do the line. I could do it with this. This is the line tool. So I could say, give me a line. And then all I gotta do is start here and just make sure that it goes through there. And then start here and just take it up through there. Right? And if I've got the points, right, I just need to start on one point and then just make sure my line lines up with the other point. And then go the other one. Yeah, like that's a doubler, but that's a dash line, right? We don't want a dash line, so. Okay, so in black, we have graphed y equals negative 3x minus 3. What are we going to do to get the absolute value of that? So we're going to say, oh, that's at negative 3, so where should it be? Okay, this will be up at positive 3. This is at negative 6. This is at, see, here's the value of having lots of points, right? This point is at negative 9, so I just follow straight up and go to 9. And then draw this. And don't forget to sketch over this. Okay, so you could make that line heavier, right, just to indicate, or use a different color, you know, bring a different color pen or a pen and use pen and pencil. Okay. Graph it. All right, let's practice graphing, because I think you might need some practice graphing. Okay, so I'm using the color one, right? If you don't have a color one, then you can graph the two graphs differently. And I'll show you, because I'll do a thick line for one too. All right, first thing, if I'm going to graph this, I want my window to match what I'm seeing there, right? That way when I've got the graph, the aspect ratio may look a little different, but it should look the same, right? So I want to go from, so let's call that negative 10 to 6. Negative 10 to positive 6 by ones. My y values are going to go, I'm going to go negative 11, because that way I can see negative 10, and I'm going to go to positive 11. Again, it's because I can see negative, or I can see the positive. Okay, also by ones. Okay, now if I just hit graph, we're just going to see that. So that should match that. There's no big grid on there. Okay, I'm gonna go to y equals.
This is the X max is still time on the window.
What? Should be fine.
Oh, right. Should be 6. You're right. Good point, right? See, because you said that doesn't look like the thing there because it's like spread the same, right? So good point. Okay, so now hopefully that looks relatively similar. We're going to go to y equals. We are going to graph negative 3 halves x. So I'm going to put down a bracket there. Go negative 3 divided by 2 x minus 3. And we're going to graph that in blue. So we're just going to look at the graph. Say, does that look like my ridge? Yeah, pretty close, right? So at least it's going in the right direction, right? It's going through negative 3 on the y-axis. It looks like it's going through positive 2, or sorry, negative 2 on the x-axis. Okay, yeah, looks about right. Now I want to do the absolute value. So I'm going to try something. I'm going to do 2 things. So I'm going to go down here. I'm going to pull out the absolute value function, right? And I'm going to say math, and under num, number 1 is ABS. Okay. Notice it gives us the absolute value, right? And I'm going to say vars, go over to y vars, function, and there's where I can find y1. So I'm going to say, I want you to graph the absolute value of y1. And here's what I'm going to do. For those of you, I'm going to make this a thicker line, right? So I'm going to change this. I think on this I hit enter. Okay, so I'm going to leave the color as red, and that shade above, that shade below, that's give like little dashes, that's a dash. Okay, thicker line. Okay, if you're using a grayscale calculator, really when you're on there, you only get one choice, right? All it'll do is change the line. So we're going to draw a red but thicker line, right? So we expect to see a thick red line here, and a red line here, and a blue line going down, right? Okay, so we'll say OK, and graph. Okay, so there's our blue line. Here comes the red line on top, supposedly thicker. I don't know, it doesn't really look thicker, but okay. And there's the red line. Should have used green, because you got the idea, right? So on your calculator, if you have a black and white, or sorry, grayscale calculator, then just move over to the left of the y2 equals and change it to be a thicker line so that you can distinguish one line from another.
It's already on the thicker line. I can make it thinner though.
Oh, okay. If you got a color calculator, don't worry about it, right? I mean, it's just, you're going to see the color. Okay. And if you don't want to be bothered making a thicker line, just watch as it graphs, and if you are saying, I think this is my vertex form of the line, then it should basically not draw anything else. Like I shouldn't see anything else happen. Okay, but, okay, state the intercepts of this, which is the green line. So what are the intercepts? So what's the x? Now notice it says state, right? What's the x-intercept? Okay, so the x-intercept, -2. What's the y-intercept? +3. State the domain and range. What is the domain? X belongs to the reals. There's a nice formal domain statement. You can write X belongs to the reals, right? That's fine. What's the range? Yeah, so set of all y, should have been a such that. Set of all y such that y has to be greater than or equal to 0, right? It's an absolute value, which means it must be positive, okay? Or 0, it could be 0. 0 is kind of Switzerland, it's neutral, right? It's neither positive nor negative, it's just sort of it's the Switzerland of numbers. So I'm not taking sides. You guys over there, you can be positive, you guys can be negative. Just here in the middle. Express this as a piecewise function. Okay, now start paying attention. All right, so here's the thing, right? If you graph this, you got to use absolute value bar, right? But we could make this into 2 separate functions, right? So we could say y is equal to, all right, so which branch of this is, when are these guys the same? So over here, right? So if x is less than or equal to -2, then the function is just the same as the original function, right? So we're going to say y is equal to, so the original function, all right, actually we're going to do it this way. Y equals, and because we got two functions, right? So what we mean by piecewise function, right? We're going to define it twice. It's equal to negative 3/2 x minus 3 if x is what? So when are they the same? When x is less than or equal to negative 2, they're the same, right? So if x is less than or equal to negative 2. Otherwise, it goes down here. So what do we have to do with this to make it go up there? We have to reflect it. How do we reflect it? We change it to a negative, right? So we take the negative of it. So watch. We're going to go, it's the negative of negative 3/2 x minus 3. If x is greater than 2. Okay? Now, you could simplify this, right? You could write it as 3/2 x plus 3. Okay, and say, well, if x is greater than or equal to 2, right? I'm sure that was said and just not written, but good catch. Okay. This is why you guys should check through tests, right? Check and say, oh, yeah, wait. There's a half a mark I rescued. There's a half a mark I rescued. Okay, so it's the negative of the original function. So it's the original function where the original function is positive, right? Not going to change anything. But, and where is that? Well, hey, that's a negative 2, right? Okay, how do we figure that out? We would have to find the x-intercept. How do we figure that out? Well, we'll take this guy and we'll set it equal to 0 and we'll solve for x. Okay, so if we did it algebraically, we would set this to 0, move the 3 over, multiply by negative 2/3, end up with negative 2 for x, right? And say, oh, it's going to be 0 at this point. Okay, now here we're given, I mean, we drew the graph and we can see where the intercept is, okay? So we say, where these guys are the same, then just leave it, right? The original function will be positive, so I don't need to change it. But where the original function is negative, I need to take the negative of it, right? That's how the absolute value function works, right? It says if your values are negative, take the negative of a negative, which gives you a positive, which is what we want out of the absolute value function. Okay? So, and we could say that y is equal to negative 3/2 x minus 3 if x is less than or equal to negative 2. And it's equal to positive 3/2 x plus 3 if x is greater than, sorry, just greater than 2. So I could go here, turn this on, go to y equals, and in black, I'm going to graph 3/2 x, so bracket 3/2 x plus 3. So now my black line should, well, okay, it's going to also be coming down. We're going to ignore the negative portion of the black line. Okay, so ignore the negative, but then it should overwrite that. Okay, so you can see, so we're ignoring all of this, right? So this, the red line is, sorry, the blue line, which is also under the bracket. Let's take out the red line. Let's take out this absolute value. So to do that, I just go to the equal sign and hit enter, and it won't graph it. So here's the blue line, right? That's negative 3/2 x plus, or minus 3. And here's the black line. It's positive 3/2 x plus 3. And we can see that what's left here, covering this up, is the absolute value, right? So piecewise, we want the blue line at negative 2 and below, and we want the black line above negative 2. Okay, make sense? Of course not. You have to do a bunch of these, right? It's never going to make sense. You'll sit down on a test having looked at this, and you'll go, I don't know what any of this means. So you got to do a bunch, right? Based on the results of your quiz, you might have to do a whole bunch more. Like, so remember, what's assigned isn't necessarily what you're going to do, right? So, you know, you're getting 95s, and the assigned's like, yeah, okay. You look through and just say, I think I know how to do all of these, and I'm willing to risk it on the test, but, you know, indications are that I'm probably taking a good calculated risk. And if you've been doing that up to this point and scoring 40s, then your calculated risk is not working, and you really do need to do a bunch, right? Like seriously. You know, it's like calculus now. The only way that you do calculus is you do calculus. Like you seriously have to just pound through a pile of questions. Okay? No matter how good you are, you really have to just, you know, practice. It's the only way you're going to get good at it, right? So you want to sit down on a test, look at a question, and be able to at least recognize, oh yeah, that's one of those. I've done like 10 of them. I know what to do here. Okay? Yeah, you might make a mechanical error here and there. Whatever. That happens, right? I do it all the time. That's why I go through somebody's key and say, okay, who's gets really, you know, oh, look, I got this one wrong. All right, I'll fix that. Okay? So math teachers are always checking their key with somebody, another math teacher or a student in the class, or we're looking to see, okay, where do we disagree and why, right? Anyways, for y equals the absolute value of 2x squared minus 5x minus 3, sketch the graph by first completing the following steps. Algebraically determine the intercepts, right? So we need to know. What do we know about 2x squared minus 5x minus 3? This guy here. It opens up. It is vertically stretched by a factor of 2, and it has a y-intercept of -3, but we need the intercepts, right? So how do we get the intercepts? Set it equal to 0. So 2x squared minus 5x minus 3 is equal to 0. Then we hope that it factors. Okay? So we factor it. I mean, otherwise it's an ugly question, and we're not going to get ugly at this point, right? We want something that's relatively straightforward. All right, so you know, right? It's like a -3 and a +1.
Oh, yeah.
But do you know where to put the -3? Where's the -3 go? First set or second set? Second set. Okay, this is negative, right? What's that tell me? And it's a 3. It tells me it's a 3 and a 1, and one of them is positive and one of them is negative. Okay, so if I put -1 here and a +3 here, and I then, okay, now I want to FOIL it out, right? So 2x squared minus 6 plus 1 is -5. -3. Okay, good, done, right? How long does that take to do? Not long, right? What does it ensure? That from this point on, everything's correct, right? Because this is no longer, this isn't grade 10, right? Hey, factor this. You get it wrong, it's like, okay, lost a mark. You get this wrong, it's like, everything is wrong from this point on, right? Like, you can't do the rest of the problem. Okay, so we've got the intercepts. Algebraically determine the coordinates of the vertex. Really?
Yep.
Okay, wait a sec. So before we go on, what do we know? We know that x, because we haven't actually determined the intercepts, right? This is like you guys. Oh, I factored it, I'm done. No, it said solve this. You must get the x values, right? Now most of you, not most of you, those of you that blew it on the quiz, you got it on the cube, right? Because you recognize, oh, right. I have to actually solve this. Okay, so x is equal to what? -1/2. Well, you got 2x plus 1 equals 0. So 2x is -1. So -1/2, right? And +3. Okay. I don't care how you factor, just that it's factored correctly. I don't care how you get these, just that you get them correctly. So this is the slow way, right? That's the fast way. Okay. Okay, -1/2 and 3. That's 3. That's -1/2. This thing opens up, right? So we know this. Why do we know it opens up? Well, how do we know it opens up? The A value is positive, right? Where's the vertex? Well, I know the x coordinate of the vertex is halfway between these two guys, right? Which is like, all right, they're 3.5 units apart. Half of 3.5 is 1 3/4. It's 1 3/4 units. It's at 2 1/4, which we will call 9/4. Okay. But we're going to complete the square on this. When we do, we're not going to be surprised if we see 9/4 sitting in it, right? Or maybe not. Is that right?
It's not 9/4.
Wait, they're 3.5 apart. What's half of 3.5? 1.75. Right? Oh, 1 point. It's 1 1/4. 5/4. 5/4. Okay. All right. How do we algebraically determine? We complete the square. So we go 2 x squared minus 5 halves x space minus 3. Now we got a positive 2 there, so we know we're going to be subtracting 2 times something, and that something goes here and here, right? And it's going to be a positive something here and a positive something here. Okay. So y equals 2x minus, what's half of 5 halves? 5 fourths, right? 5 fourths. When I square 5 fourths, what do I get?
5/8.
No. Yes.
Whoops.
Oh. I need a Nerf bat to shoot you with, right? Just enough. Half a mark. So, look, here's the worst thing about minor mistakes. If all it is yeah, okay, it costs you half a mark because yeah, but it's when that mistake continues on into further stuff, it just tends to make things that, you know, we gave you that are relative. This is not nice, right? It's like 5 fourths, but it tends to make things that are relatively nice reasonably ugly. And that's where stuff starts to go into the, hey, now I've just spent 10 minutes on this question and it's just looking worse every moment. Anyway, okay, so I need 25/16. Now I need 2 times 25/16, right? So 2 times 25/16. Now remember, I'm adding it, I'm subtracting it, but I got to multiply it by positive 2 on the way out. So it's minus 2 times that, right? Okay, so should we work this out? So what's 2 times 25/16? Redeem yourself. Now the denominator is an?
Oh.
Okay, so the 2 goes into 16 8 times, right? We get 25 over 8. 3 is 24 over 8 minus 25 over 8. What does that give me? Minus 49 over 8. Right? My God, it's like you just lost all the marks on this question, right? Now, it wouldn't happen if you were actually doing this on paper, right? Anyways, so we got negative 49 over 8. So that's the equation, right? Algebraic term of the quote, but it says, where's the vertex? Where is the vertex? Five fourths and how could you check that? Watch. Yeah, you could graph it, right? What was the original function? Okay, so I'm gonna turn this on. Okay, I'm gonna go zoom 6, turn back to a standard window. I'm gonna go to Y. Okay, it's drawing. I don't want it to. I'm gonna hit on. On will break the calculator, and that's more of a B-R-A-K-E. It'll stop it from doing what it's doing. Okay, so because it could be graphing something really complicated, and you're gonna sit there and say, "Oh, wait before I can enter." I'm going to clear everything out of here. Okay, and you go back. What was the original? 2x squared minus 5x minus 3, right? 2x squared minus 5x minus 3. I'm going to go down here. I also think it's 2 bracket x minus, I like to put these in parentheses. You don't really need to, but I'm going to. 5 fourths squared minus 49 over 8, right? Minus, and again, you don't have to, but I'm going to. Right? Now, when I hit graph, now if you're using a grayscale calculator, you're going to want to set y2 to be thicker. Here, what are we going to see? You're going to see it draw the blue graph, and then it should draw the red graph right over top. Go out and buy a colored calculator. It will help you in that. No. Okay, blue line. This better work, or it'll just be too embarrassing. Blue line. Oh, there it is. Yeah, I know, right? You can see, it's like, I think it takes it longer to graph that, right? Because I'm not sure how it does it. Like, I don't know if it takes the x minus 5 fourths and actually squares that and then adds the other. I think it doesn't. I think it's just putting values of x in and working them out. And you can see that doing that with 2x squared minus 5x minus 3 didn't take. Blue line graphed fast, right? Zzz, you know, and then red line is sort of like, I got some thinking to do here, right? So it takes longer. Okay. So we know that so far we're going good, right? We're going good. Use the X-Intercepts and Vertex to sketch the graph. Okay, x-intercepts were what? -1/2. Let's do this in red. -1/2. +3. What else do we have? We know the y-intercept is what? -3, right? I mean, you know, it says intercept, so I don't think at any point it said get the y-intercept. Okay, and what else we got? We got 5/4, 1 1/4, and this is -6 1/4. Okay, so 1 1/4, -6 1/4. Okay, oops. Fill the grid. Okay, fill the grid. Don't shortcut. I should have shrunk this a bit. Okay, use this. Okay, so we sketched that, right? Does that look like that? 1, 2, 3, 4, 5, 6. Yeah, it kind of looks like that, right? Don't have the windows set the same, but it's like, yeah, okay. Use the graph to graph. So what do we do to get an absolute value graph? Flip the negative, right? Okay, so that which is already positive stays positive. This, I know this point, so I'm going to put it up there. I know this point, I'm going to put it there. And it's a parabola, so it's not going to be a W. Right? It's going to have a curve in the middle. Okay? So the green line, that's the absolute value. The red line, that's the original. Use graphing technology to verify your graph. Okay, so that's y equals, let's do it in green. I'll go down to y5 because that's green. So I can do absolute value. So I can do this, math, over to num, ABS. I can retype, so 2x squared minus 5x minus 3. Okay, so I now expect, it's probably going to regraph. No, it says, yeah, those two graphs are the same. So now I'm going to draw the green line, and there's the green line. Okay. I could set the window to match this, then it would look a little nicer. But, you know, I can see that that's. Okay, so are we good? No, because you have to do a bunch of these, seriously, right? Use graph, so yes, we did that. State the domain and range of the absolute value. So what's the domain? X belongs to the reals. I'm going to give you the short version. What's the range? Greater than or equal to 0. Now, it won't necessarily always be, had this been a graph that looked like this, and I did the absolute value, it would be the exact same graph, right? Or, if the original graph had looked like this, and I did the absolute value, then it's going to be, not that, but, you know, it's going to be that. Right? So if I take the absolute value of a graph which has already got a range which is greater than or equal to 0, it's just the exact same graph. If I take one whose range was less than or equal to 0, then it's a total reflection. Right? Express this as a piecewise function. Well, this is interesting. So these guys are the same here and here. Okay, so when is it the same? So we'll say y is equal to 2x squared minus 5x minus 3 if what? So what can we say about the x values? They're either less than or equal to -1/2 or x is greater than or equal to 3. Okay, those two functions we'll have, because that's when this guy is positive anyways, right? Or, what do we say down here? The negative of. I don't mind you leaving it like that. Like, just seriously, just say it's the negative of this, right? So I'm going to say you don't necessarily have to write it as negative 2x squared plus 5x plus 3, but you should know that it is the same, right? So if you get a multiple choice question, it sort of gives you these, and one, you know, it could be written like this, but it could also be written negative 2x squared plus 5x plus 3, right? If what? It's between negative 1/2 and 3. Then we have to take the negative, right? Because now it's down here. It has negative values. How do we make them positive? We take the negative of. So we take the negative of the function when it's between these two values, right? And we'll let the zeros go with this guy, right? I mean, technically, if you wrote equals here, it wouldn't be wrong, right? Because that they would just include the zeros. Yeah.
So, you could put the negative half in 3?
Sorry. Oh, you mean like here? Like,
Yeah.
if you wrote equal to, it's not wrong because it's really 0 at those points. So, but let's say that our standard will be that we will put the equals with the original function, with the positives, right? So we'll include the zeros with the positive of it, and we will exclude them with the negative, right? If you do that, then when you look at your answers in the book, you'll be looking at the same thing. I mean, technically, if you didn't put the equals here and put them here, or if you put them in both places, it's not wrong, because they're just 0. But you can't, if you left them off of both places, then it would be wrong, right? You'd lose half marks. Like, we got no zeros now, right? Like you've left out a point. Yeah, 2 points.
So do you always write it negative up, or can you just put the negative in?
So, if I'm writing, I'm just going to say the negative of. But if it's a multiple choice question, you may see the negative through. If I'm keying it, I'll write them both down, right? Just so that if I'm looking at yours, I look at my keys, I don't have to think, right? So I'll do that a lot. If there's a couple of ways to do a problem, I'll do it both ways.
But it wouldn't be wrong.
But it wouldn't be wrong to put the negative through. I just like it this way because it's really back to the definition of absolute value, right? It's x if x is greater than or equal to 0, and it's negative x. So think of it as, like, think of it like this. Okay, so it's the function if x, whatever, right? Let's say greater than or equal to a, and otherwise it's the negative of the function. And then just realize, okay, if it was originally written like this, I'm not going to mark you wrong if you go negative 2x squared plus 5x plus 3. I might put a multiple choice where you don't see the negative of, right? Where's the negative of? Oh, wait, I just actually have to distribute the negative through. We're done, right?
Yeah.